All right, so we're going to finish up section 2.3. All right, so we're still talking about the variability, talking about standard deviations and variances. And we were talking last time about the interpretation of the standard deviation. And the standard deviation is sigma. Okay. And recall, mu, this is the mean of the random variable, x, or whatever random variable you have. And sigma, this is the standard deviation of x, all right? The mu, the mean, tells you what's going on in the middle. Like in the middle of the distribution of x, what's happening. The standard deviation tells you how spread out the values are, all right? So we get this measure of the standard deviation. So what does this standard deviation tell you? So obviously mu is the average. So what is sigma? And so we said that sigma, this is a typical distance to the mean. Right? So if I take mu and I add a standard deviation and I subtract a standard deviation, that, x typically has values in here. All right? So not uncommon for to have values there. All right. So now I'm going to give you a rule, and it's called the empirical rule. And the empirical rule is this. All right. And this is for random variables having reasonably large number of values. Right, so if x has values from 0 to 10 or 0 to 100, the 5 maybe is not enough, all right? But so for random variables having a reasonably large number of values, all right, these two things are true. One, all right, the probability that x, the random variable x, is within 2 standard deviations of the mean. In other words, between mu minus 2 standard deviations and mu plus 2 standard deviations. So down here, there's mu plus sigma. If we add another sigma, we have mu plus 2 sigma, mu minus 2 sigma. Right? So if we're so the values between here and here, that this probability will be large. And so how large? Like 0.9 or higher. All right, so 90% of the time or more. All right, so if we could look at this guy. This guy's going to occur 90% of the time or more. All right, so there's going to be some x values, some possible values of x in here. So we expect that to occur a lot. Those values should occur a lot. All right. The second one, the second rule, all right, has to do with being within 3 standard deviations. All right, so the probability that my random variable x, of course it could be random variable y, whatever we call a random variable, that is within 3 standard deviations of the mean, All right, so here we're talking about between mu minus 3 sigma and mu plus 3 sigma. But this will be close to 1. So basically, you know, almost all values of x will happen. So let's say this, almost all the time, my random variable x will be in here in this interval. All right. That's 90%. So if I add another one, go over here, mu plus 3 sigma, mu minus 3 sigma, well, I expect almost all values of x. Now, there could be values of x outside of here, but they're not going to be very likely. Their probabilities are going to be close to 0. All right, so almost everything's going to occur within 3 standard deviations of the mean. All right, and that is the empirical rule. 90% or more within 2 standard deviations, almost all of them within 3 standard deviations. Okay, so now we're going to do an example. All right, so we've already looked at this distribution, the sum of 2 dice. All right, so we're going to roll the dice, the sum of 2 dice. And we've done this distribution a few times. Hopefully you'll remember where we got these numbers. All right, so we have, we can roll a 2, a 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, all right. So there's 6 times 6, 36 possible rolls. So 1 and a 1. So this guy, there's only one way to roll a 2, and there's only one way to roll a 12. I can roll a 1 and a 1, or a 6 and a 6. There's 2 ways to roll a 3. I can get a 1 and 2, or a 2 and 1, if I'm thinking about rolling the dice in order. So this is 2 over 36. And this just steps up till I get to 7. 4, 6, 7. And then it goes down. All right, so let's review. All right, so there's my distribution. And here's the question. All right, so, the empirical rule says that, almost all values should be within 3 standard deviations of the mean. 3 sigma of mu. That's what the empirical rule tells me, all right? So is the actual probability that the roll of the dice, the roll of the dice is within 3 standard deviations of the mean. 3. And when I said sigma, that's the standard deviation, mu is the mean. All right, so mu we said was 7. In order to get the standard deviation, we have to calculate it. So sigma, this is the sum. And we're going to use our improved rule, our faster rule. So this is x squared times p of x. And then we're going to subtract mu squared. And so here's mu. That's my center. And we know that's the mean without even doing the calculation because this is a symmetric distribution. The probabilities on the left side are the same as the probabilities on the right side. So the center value is the mean. And all right, so what is this? So x squared, so 2 squared times 1 over 36 plus 3 squared times 2 over 36 plus 4 squared times 4 over 36 plus 5 squared. What did I do wrong? 2, 3, 4. Oh, this is 3. Okay. 5 squared times 4 over 36, and I'm just going to dot, dot, dot. Plus 12 squared, x squared times its probability. Okay. And then I subtract 7 squared from that number. Okay. So I'll have, this is all this over 36. And I have 4. 2 squared, and I've got 3 squared, 9 times 2, that's 18. Now I got 16 times 3, that's 48. Plus, and again, dot, 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 I'm going to have 12 squared, that's 144. And I kind of made my line too long, but anyway, minus 7 squared. And if you put all this in the calculator, this guy actually equals, actually that's sigma squared. Right, and so this is 5.833. And then so sigma, the standard deviation, is the square root of that. And this is equal to 2.415. All right, so this measures how spread out these values are for this distribution. All right. Okay. So the problem that was asked is what's the probability of being within 3 standard deviations of the mean, right? So we want the probability that x is in the interval, mu minus 3 sigma and mu plus 3 sigma. Right? Because that's the interval within 3 standard deviations of the mean. This is the mean minus 3 standard deviations, mu plus 3 standard deviations. So what is that value, right? So mu minus 3 standard deviations, right? This is going to be, the mean was 7. We call mu is 7. Sigma is 2.415. Right? So it's going to be 7 minus 3 minus 2.415. Right? And that equals negative 0.245. And then mu plus 3 sigma is 7 plus 3 times 2.415. So this is actually equal to 14.245. Okay. So then if I make an interval, here's, negative 0.245 and 14.245, what's the probability that x is in here, all right? So what values of x are in between here and here? Well, the lowest value for x was 2. Okay, so here's 2, and then 3, and then it goes up to 12. All right? So my possible values of x are all in here. What's the probability of being between 2 and 12? It's 1, right? So the probability that x is within 3 standard deviations of the mean, right, which is another way of saying that x is an interval mu minus 3 sigma, mu plus 3 sigma equals 1. So the empirical rule said it should be close to 1. Well, is 1 close to 1? Yes. All right, this is closer to get to 1. So this is consistent with the empirical rule. Great. All right, so what about within 2 standard deviations? All right, so what's the probability? A continuation, another question. What is the probability that x is within 2 standard deviations of the mean? All right, well, so I need to know the interval x minus 2 sigma, or not x, mu minus 2 sigma, the mean minus 2 standard deviations, the mean plus 2 standard deviations. Okay? So this is going to be 7 minus 2 times 2.415. This is going to be 7 plus 2 times 2.415. Okay? And that is 2.17, and this one's 11.83. Right, so what's the probability of being in between those two values? All right, so if I, here's 2.17, 11.83. All right, so what values of x are going to be in between here? All right, well, again, the smallest value of x, the lowest roll is a 2. Well, the 2 is going to be over here. And what about the next one? A 3 is going to be over here, and then 4, etc. All right. Over here, what's the largest roll? It's a 12. The 12 is outside here, and 11 is inside here. All right, so the probability of being within 2 standard deviations of the mean, this is the probability that x is between 3 and 11. So if I go back to my distribution, all right, so what I want is the probability of being between 3 and 11, so that's all these different probabilities. And I could add all those up, but there's a faster way to calculate than saying 2 plus over 36 plus 3 plus 36 all the way over, right? And that is using the complement rule. So the probability that x is between 3 and 11 by the complement rule, this is going to be 1 minus the probability of not being between. Three and 11. All right, so the complement rule tells me this. The probability of A is 1 minus the probability of A complement. So what is A complement here? What's the complement of this? That's going to be 2 and 12. All right, so this is 1 minus this probability is going to be P of 2 plus P of 12. So we're going to subtract those out. All right, so this is 1 minus 1 over 36 plus 1 over 36. All right, so 1 minus 2 over 30. Oops. Put that on this page. Oops. Okay, this is 1 minus, write that again, 36 plus 1 over 36. All right, and so this is 36 minus 2 over 36. So that's 34 over 36. We put that in the calculator, and that gives us 0.944. All right, so to recall what the empirical rule told us about that. All right, so the empirical rule said the probability that x is within 2 standard deviations of the mean is going to be large. Usually it's going to be 90% or higher. So is this 90% or higher? Yes, it is. 94.4% of the time, we will My role would be within 2 standard deviations of the mean. So this is yes. So again, this is consistent with the empirical rule, which I'm just going to write ER because I'm out of space. Okay, let's do another example. Right, this time I'm going to tell you the mean. All right, so here's an example. Say the ACT has mean 20.8 and standard deviation 4.8. All right, so let's say also that we have a student who scored a 31. All right, so here's a question. Do a large percentage of students have a higher score than this? All right, and we're going to use the empirical rule to figure that out. All right, so I'm going to start with my mean. All right, so when it says mean 20.8, that this guy is mu. Standard deviation, its symbol is sigma. All right, so I'm going to make an interval. I'm going to start with mu in the middle, so I have mean 20.8. All right, and I'm going to add 2 standard deviations and subtract 2. I can do 3 as well. So this guy right here, this is going to be 20.8 plus a standard deviation, 4.8. All right, so that's going to give me 25.6. And I'm going to add another one. I'm going to add another 4.8 to that, and that's going to give me 30.4. And I'm going to do another one. I'm going to add to that. And let's see, it'll be 35.2. Basically, this is mu plus 2. So this distance here is a standard deviation all the way across. Now I'm going to subtract 4.8. All right. So this one, this is going to be 16.0. Another 4.8. This is going to be 11.2. And another 4.8. All right. So it'll be 6 point. So I'm going to say just 4. All right. So here's the deal. We expect inside here, within 2 standard deviation, that at least 90% of students should score in here. All right. So if I have 90% in here, then the probability of being outside here, which is going to be either here or here, all right, that's at least 90%. Then this guy and this guy together, so fewer than 10% will score, higher than 30.4 or lower than 11.2. Now I don't know if this is, I can't necessarily say this is half. I don't know if this is a symmetric distribution or not. It could be a right skew distribution, which I would have a higher probability over here and a lower. So I know that 31, all right, 31 is outside that interval. All right. So what that tells me is that I'm pretty sure fewer than 10% will score higher than 30.4. Or higher than 31. All right, I know fewer than 10% higher score higher than 31, and I know fewer than 10% score lower than 11. All right, so that kind of answers my question. All right, what about if somebody scored? What about a student who scored a 36? How likely is that? All right, well this is 3 standard deviations above the mean is 35.2. So a 36 is going to be out here. All right, so what do I know? I know by the empirical rule that almost all close to 100% are going to score between 6.4 and 35.2. So if at least close to 1, that means everything outside of here is rare. All right. So because 36, all right, is higher than mu plus 3 sigma, all right, scores higher than 36 are rare. Right. So that's kind of how the empirical rule works. Right? We got at least 90% within 2 standard deviations and almost all within 3 standard deviations of the mean. That is all I have to say today. I hope you guys are having a great time doing your homework at home. You're probably not, but or maybe you are. Maybe you're like, yay, I don't have to come to school. But either way, keep up the good work. Keep listening to the videos. Keep working on the homework. You should now have enough homework. You should now be able to do homework. I think it's 2.2. All right. Well, have a good day.